As the days warm up, the hiking group I belong to is starting to plan more frequent and longer hikes. Although we are not mountain climbers by any means, we do encounter some steep climbs. Season-wise, March to May, we are in the middle of what is considered the best time to climb Mount Everest. But what does this have to do with space? Take a good look at this photo. The European Space Agency shared this image of Mars to celebrate the 25,000th orbit of the Mars Express spacecraft. You can see 3 of Mars's famously colossal volcanoes in a row. From left to right, Arsia, Pavonis, and Ascraeus Mons, with the mound of Mars's largest volcano, Olympus Mons, at the top of the frame. The humongous volcano, Olympus Mons, is a result of the dynamic and tumultuous geological processes that have shaped Mars over billions of years. Olympus Mons is approximately 72,000 feet, or 22,000 meters tall. It rises 13.6 miles, or 22.9 kilometers, above the Martian surface. Its summit is marked by a caldera, a large depression formed by volcanic activity spanning 50 miles or 80 kilometers wide. The mountain's slopes are gentle, but its sheer size is so vast that were you to stand on its base, the summit would extend beyond the horizon. As you can see, Olympus Mons is nearly 3 times the height of Mount Everest, but with such a wide base, all of its slopes average only about 5 degrees. At such a mild grade, climbing Olympus Mons would be an extremely long but relatively gentle hike. This led me to wonder if anyone else had thought about space hiking the highest mountain in the solar system. Well, of course! A research group in Sweden did a study on what it would take to climb Olympus Mons, and they found it would take a total of 640 days, including flight time, and an insane $38 billion. That seems like an outrageous cost for a hike, but there are some things to consider above and beyond just getting there. To climb Olympus Mons, first you need oxygen. Over 95% of the Martian atmosphere is carbon dioxide, with only trace amounts of oxygen. Therefore, the air is unbreathable. You would be required to carry your own oxygen supply, and that would slow down the pace of the trek. The Martian atmosphere is exceedingly thin, about 100 times less dense than Earth's. This scarcity of air means you'd face extreme cold, with temperatures at the summit potentially dropping to minus 112 degrees Fahrenheit or minus 80 degrees Celsius. At the summit of Mount Everest in peak climbing season, it is minus 30, but it can drop to minus 60 and even minus 70 with the wind chill. The lack of air on Mars also contributes to massive dust storms that envelop the entire planet. Once dust particles are lifted by relatively mild winds, they can stay suspended for weeks at a time and be carried over vast distances. Navigation and maintaining equipment functionality in these conditions would be challenging. Your $1,400 ramp site compass from Aircraft Spruce, Canada probably still wouldn't work there. Mars offers little protection against cosmic and solar radiation due to its thin atmosphere and lack of a magnetic field. Climbers would be directly exposed to radiation, so protective gear beyond the thermal and oxygen supply systems would be a necessity. And as far as the actual terrain, Olympus Mons has a relatively gentle slope compared to mountains on Earth. Its large size and gentle gradients mean that technically the physical act of climbing it may not be as demanding as the steep ascents of Earth's highest peaks. The challenge lies less in vertical climbing and more in covering the tremendous horizontal distances involved. To reach the summit, one would have to hike nearly 200 miles, or 320 kilometers, and gain at least 72,180 feet of elevation in the process. But hang on a second. Mars has a gravitational pull that is just 38% that of Earth's. The reduced gravity on the red planet would fundamentally alter the hiking experience, providing advantages. You would find your steps lighter, and it would be easier to carry the weight of the oxygen tanks, so the strain on muscles and joints would be markedly reduced, allowing for longer distances to be covered with less physical fatigue. Piece of cake, right? On the flip side, the reduced gravity could affect your sense of balance and coordination. Humans evolved under Earth's stronger gravitational forces, and it might be a struggle to adapt. Furthermore, the lower gravity could have long-term health implications, such as muscle atrophy, bone density loss, issues that have already been observed in astronauts after extended periods in microgravity environments. I could not find the breakdown for the actual days out of the 645 needed that were just for the hike of Olympus Mons, but it would take 270 days just to get to Mars. It didn't say if the total included the return trip. Considering what's involved, the $38 billion price tag no longer seems that outrageous. So although summiting Olympus Mons is in the distant future, I am sure it will happen, just not in my lifetime. Meanwhile, Mount Everest is definitely closer, and the cost averages between $30,000 and $160,000. That must be why it's becoming so popular.